In this video, we defined the distance between two vectors in UV denoted by d of u comma v as or equal to the length of u minus v. Okay, we want to prove these three properties. They're proof of A. By definition, the distance between u and v is the length of u minus v. But that's the same as, I don't know if we need to say this, but u minus negative v. The thing is, when you add two vectors, you get a vector. We didn't talk about what happens when you subtract two vectors. When you add two vectors, that's why I'm doing this. When you add two vectors, you get a vector. The length of a vector is at least 0. Part A has been established. Proof for B. The length of UV, the distance between u and v, is the length of u minus v. Now, recall that the length of c times vector x is equal to the absolute value of c times the length of vector x. Okay, and we're going to use this. So, equals goes there. So, this becomes negative 1 times v minus u. And I guess the theorem that I just stated is used for this one. So this is equal to the absolute value of negative 1 times the length of v minus u. But the absolute value of negative 1 is 1 times the length of v minus u. Well, that just equals to the length of v minus u, which is d of v comma u. So I did show that this equals eventually this. It equals that. Now D is probably the more interesting one. I meant to say C, excuse me. The proof for C. Well, the distance d of u comma w is the length of u minus w. But u minus w is the same as u minus v plus v minus w. This is one vector, that's another vector, and the sum of those vectors is u minus w. But we know from the triangle inequality that this is less than the length of u minus v plus the length of v minus w, which is equal to this here is the length of uv plus this is, or the distance, this is the distance between v and w. And that's exactly what I set out to show. Okay, this is exactly what I got. I showed that this mess, which is right here, is less than or equal to this. That is, the distance between u and w is less than or equal to the distance between u and any vector plus the distance of that any vector and w. You can insert any vector you want. Has to be an Rn. this theorem has been proven. If you like videos like this, subscribe to my channel. Leave a comment. Tell your friends and enemies about my YouTube channel. Most of all, watch and learn.